Afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And for the next hour, we're going to go over all things math for your certification exams. So we're just going to go ahead and get started here. Welcome to everybody who joins me live. We're live from 5 to 6 every Tuesday, and then it's recorded. So you can go back, you can see all the different sessions that we've had in the past Tuesdays. There are 10 problems in each session. And during those sessions, I try and show you as many tips and tricks that I possibly can so that you can be successful in your certification exam, specifically for math. We understand how you may have an aversion to math, and that's okay. My goal, my objective is to just get you through these types of problems as quick and efficiently as possible so that you can pass your exam. Remember, the number one thing to remember is you don't need to get 100%. Understand that about 75% is all you need to get correct in order to pass. So if there are problems that are giving you a hard time and it's just really bugging you out, then you know what, just let them go. So you gotta kind of feel them out. But for the most part, this is all about where I'm not necessarily teaching you the math from scratch. I'm teaching you how to get the right answer. I am live on our Facebook page. So if you're watching on Facebook, welcome. You can also comment if you have any comments or questions as I go through the problems. And then on YouTube, you can go ahead and comment. We're live there for the next hour. And then if not, if you're watching this on the recording, then go ahead and comment anyway. We see the comments and we'll answer them if necessary. Make sure you've got your calculator, make sure you've got your scratch paper, and off we go. First problem we have says Sam has a job assembling motorcycles. On average, it takes him 36 hours of labor to assemble 2 motorcycles. How many days will it take him to assemble 15 motorcycles? There's 2 ways to go about this problem. Most importantly, we have 36 hours here, and it's asking us in days. We have 2 different units of measure. You can, according to what you want to do, change your hours into days or change your days into hours before you start doing anything. More importantly, go to days because that's what it's asking you to do. But you can convert your units before you start the problem, or you can kind of work it out and then convert it at the end. Again, it's all about preference. And when I do these, I try to do them in a couple of ways, or the ways that are mostly more popular, I guess you could say, of what people have been taught or will gravitate towards when they solve these problems. If it takes me 36 hours to assemble the 2 motorcycles, then I know that I can just go ahead and take this and convert it into days. I know that for every day, well, let's do this. 1 day is equal to 24 hours. And if I want to go ahead to convert from hours to days, I'm going to divide. So that's why I do 36 divided by 24. So I'll just get rid of that there. When I do that, I get 1.5. So 36 hours, which makes sense. 36 hours is 1.5 days. Now I can go ahead and set up my proportion, because it's giving me hours to motorcycles. So our matchy-matchy, if you don't know what that is, matchy-matchy is when we show you how to set up a proportion, you use the units or you use the verbiage that they use in the problem to help you out to make sure that you're setting it up correctly. I want to go hours over motorcycles. So that way, every value on the top is hours. Or I'm sorry, I should put time. It's time, or in this case, I see hours in the problem. I meant here days. Let's do days. Sorry about that. Okay. So with days over motorcycles, I know that it takes me 1.5 days to assemble 2 motorcycles because that's what it tells me in the problem. So then how many days will it take to go 15? Well, I don't know how many days because that's what we're trying to find out. And then 15 is the number that I'm looking for. Now we just go ahead and cross multiply and divide. When we do that, we'll do the 1.5 times 15. And again, I'm showing you this to work it out so you can see it, but I do not want you to be writing so much. Again, remember, time is your enemy on this test. So the more that you can do in your calculator, so everything I'm doing here, I need to write that a little neater. So in my mind, I'm doing 1.5 times 15. Here's 1.5 times 15. Do it in your calculator, right? Equals 2x. 1.5 times 15 is 22.5. I'm going to move it over here. 22.5 equals 2x. It's still in your calculator. That's why learn to use your calculator, be efficient with your calculator, because then you don't ever have to write any of this down. You would cross multiply. I would do the 1.5 times 15, get the 22.5 in my calculator. Then I know it's cross multiply and divide. The only thing I've got left to divide with is this 2, which is this right here. So once I hit divide 2 in the calculator, really without writing anything down, it spits out 11.25. Now, what does this mean? This means X were days, it's 11.25 days. I look here, oh, I only have 11. What we need to know is when we're talking about units, whole units, in this case, it's asking for how many days. Days in this case are whole units. Yes, I get it. You can work 0.25 of a day, right? That's 6 hours because, you know, a quarter of a day, 24 hours divided by 4 is 6. But that's not what we're looking for. It's how many days. If it takes me 11.25 days, then whatever it is other than the whole number, round up. So 11 days would be fine if it were 11, but it's 11.25. Therefore, it needs to be 12 days. You, on the 11th day, will not have a full 15 motorcycles, but on the 12th day, you will. Does that make sense? Okay. And then just the other way of doing it, it's basically the same way. It's not really another way, but that's when you convert before. If we did it the other way, we would have to take into account, right, 36 hours for every 2 bike, which equals 15 bikes over X. Then that gives us 36. Now let's do that. 36 times 15 equals 2X. 36 times 15 equals 540 equals 2X. X equals 270. Well, what does that mean? That means it's 270 hours, but because there are 24 hours in a day, cancel, and we do, again, you'll get 11.25. Okay, so no matter which way you do it, whichever way seems easiest for you, that's what I want you to do. Okay, all right, moving on. It says last month, the local gas station sold 18,590 gallons of gas. This month, the same gas station sold 20,230 gallons of gas. Find the percent of change to the nearest tenth and identify it as an increase or a decrease. Okay. Percent increase, percent decrease, pretty straightforward as long as you know how to set them up. But here's how you're going to know what to do. Okay, we have last year. This was last year. This is this year. Is 18,000, and I'm just going to round, 18,000 bigger or small? Well, let's do this. Is 20,000 bigger or smaller than 18,000? And of course, you're going to say bigger. Well, if it increased from last year to this year, or last month to this month, that's what it was. I said year, but it's month. If it increased from one month to the other, that means it was a percent increase. Going at my answer choices, I see there's increase, decrease, increase, increase. I can get rid of these two right away. Okay, which it may not seem like a lot, but you have a 1 in 20, you have a 20% chance of getting it right just by guessing. Okay, but now you've eliminated 2 right away. So now you went from 20% to 33%. I know it may not sound like a lot, but in the grand scheme of things, it's better to pick 1 out of 3 than it is a 1 out of 5. Okay. So any little advantage that you can get, do it. Okay. Now, how do we find percent decrease? It's as simple as taking your new price minus your old price and divide it by the old price. Okay. And that works for all of them. Like they'll say, oh, I bought a house here. I bought a house this year, then I sold it this year. Is it percent increase, decrease? Okay. But what I will tell you is this, no matter what you do, if it's on the top, if you're subtracting, if you know for a fact, which we do, that it is a percent increase, then it doesn't matter what order you put the numbers in. Granted, it does help to know that, but I'm just telling you right now, don't get bent out of shape if you can't remember this on the test. As long as you subtract the 2 numbers and you understand that the one number, the older number, is either smaller or bigger than the new number, that's how you can tell if it's an increase or decrease. So in this case, let's do the 20 to 30 minus 18,590, all divided by 18,590. Here's how you can tell whether or not it's an increase or decrease if you set it up correctly. I know that this becomes 1640. That's 4. 1640 over 18,590. Okay, because it's a bigger number minus a smaller number, which should give me a positive, right? That's positive 1640. If I did 18,590 minus 20,000 or 20,230, I would get a negative 1640. If it's a negative 1640, that will tell you that it's a decrease. But because it's a positive, that's how it works out. So that when I do 1640 over 893, I get, and I remember it says to the nearest tenth, find the percent to the nearest tenth, 1640 divided by 18,590. That gives me 0.088. Because it's looking for a percent, that's why you see the 0.88, but that's why these are in percent. So I take my decimal point, I go 1, 2 to the right, and I get 8.8%, and D is the correct answer. Okay. Okay. Looks like I got a question. Back on question 1, is it for proportion would be 24 hours. You can't do a proportion with 24 hours unless you do, there are 24 hours for every 1 day, but it doesn't work out with this. You either got to use the 36 hours or convert your hours into days. The way you convert your hours into days is by using the 24 hours. So no. Okay. All right. Next question. We've got, at a local baseball tournament of 1,500 players, 476 of the players did not record a strikeout at the plate. What percent of the players, to the nearest whole percent, did record a strikeout during the tournament? Okay. These problems can be confusing if you read them too fast, but they're fairly simple. So we have 1,500. Yikes. Getting a little wild with the pen today. There are 1,500 players. There are 476 that did, and then there is an amount that did not strike out. All right, 476 players did not, did not. And then there's an amount of players that did. strikeout. What percent of the players to the nearest whole percent did record a strikeout? So I need to figure out what this value is. And then because I'm looking for a percent, I need to take said value and divide it by 1500. Does that make sense? So there's two ways you can do this. The first way that I do it, and this is the way that I would look at this problem, is I would take, let's just go the whole way. I would do 476 divided by 1500. When I do that, I get 32%. I get 0.317 or 32%. Okay, rounded it up. These are the players that did not. Well, I know that everything has to be 100%. So if 32% of the players did not, and I'm looking for the ones that did, let's do 100% minus 32%, and that leaves me with 68. And again, you've got your calculator. Always have your calculator in your hand. I know something like 100 minus 32 might seem easy to you, but when you're in your test center and you're kind of anxious and you're staring at a computer screen, your mind does crazy things. So keep the calculator close by and do 100 minus 32. It's totally okay. You'll confirm that you were right by saying, oh yeah, 68%, and you will get the correct answer. Okay. So it's not just, I know I did the wrong number, but I got that percentage because I could just take that and subtract it from 100. That seems pretty easy to me, at least. The other way, another more common way of doing it, I think the only other way, I mean, I'm sure there's other longer ways. Take your 1500, subtract 476. That's going to give us the amount of players that did record a strikeout, and it's 1024. Then you take 1024 and you divide it by 1500, and you get, I will bet you anything, you get 68%, 0.682, which gives me 68%. Okay. Pretty simple. Two ways of doing it. Again, whichever way you feel most comfortable. Don't go into your test when you just learned something new a day or two before you're taking the test and kind of expect to know it, unless you're good at that, which people are. I'm not discounting that. So whatever way you like and you feel most comfortable with, and again, it does take practice. You got to practice these problems, but I'm just trying to show you any possible way that I can in order for you to make it make more sense to you. Problem 4, a married couple each make $40,000 per year salary. Any additional income they earn is from investments. At the end of the year, their gross earnings were $85,000. What fraction of their income was from investments? Pay attention to this type of problem, especially the first sentence. A married couple each make, each. That means they're married, which whatever is 2 people. That means that one makes 40,000 and the other makes 40,000. Another one. Any additional income they earn is from investments. So I've got 40,000 and 40,000, and I've got some investment number. And when I add it all up, I get, it's terrible, 8. I get 85,000. Well, if I know 40 and 40 make 80, holy cow, 80,000, and I take that away from 85,000, I know that I have $5,000 in investments. Does that make sense? Wants to know what fraction of their income is from investments. So that's terrible. I'm sorry about that. So you see my train of thought here. And the biggest part is to figure out how to get this 5,000. 40,000 for one of the couple, 40,000 for the other, because it said they each make 40,000 a year. At the end of the year, they pulled in 85,000. Well, 40 and 40 make 80. An extra 5 gives me $5,000 in investments. Now it says what fraction of their income was from investments. If they make, and that's what they want. They want you, this problem is assessing on whether or not you can figure out this 5,000 number. So then finally you take 5,000 and you divide it by the total, because they brought in $85,000. That's what fraction of their income that is considered income. So we go ahead and we do this. Now, all depends on, how you have to figure this out, calculator or not. You know, anytime we have zeros, 0, 0, 0 is 5 over 85, or 1 over 17. But let's just say you did it this way because you've got a calculator. So with your calculator, you did 5,000 divided by 85,000. You will end up with 0.059. All right. Obviously, these are in fraction form. So how are you going to go ahead and figure out your 0.059 with this? You've got the calculator. Okay. So just start with A. I'll start with A. 1 divided by 16, because what is a fraction? It's ultimately a division problem. So you'll get 0.0625. Obviously that doesn't work, so that's gone. We'll do 1 divided by 17 and you get 0.058. Well, look at that, 0.0588. I rounded when I saw this. It's not going to be off by a thousandth, right? They're not going to be that strict on you because I rounded. So that has to be the answer right there. Okay. And 1/2, obviously that's 0.5. And then you do 8 divided by 17, right? You can see where I'm going here, but divide the fraction to get the decimal equivalent. If you have a decimal equivalent, divide the fraction that you end up with in your answer to figure it out. Okay. Question says 4,000 and 4. It's 40,000, not 4,000. Right. 40 and 40 is not 85. That's the whole point. You have to figure out what they earned from investment. That's the missing piece. So this is the missing piece that you have to find. That's why it's here. You do 40,000 plus 40,000 plus this I, or investment, and you get 85,000. Maybe I should have made that a little clearer, because when I do that, understand that we get 80. That's 80, right? 80,000 plus my investments equal 85,000. Subtract a lot of zeros and eights here. And I get I is equal to 5,000. That's how I get my investments. Okay. All right. Next question. I like these because they kind of trick you a little bit. You got to just pay attention, especially on a computer screen for these types of problems. You're staring at it, and a minus sign may just kind of tend to disappear as you look up and down real quick from your paper to your screen. So just make sure, again, this is why we use scratch paper when we practice. You have to write this down unless you do it in your head. So I encourage you to write it down, but if you can do it in your head, great, more power to you. But you're not going to be able to write underneath the problem or on the screen. So you got to look up at the screen and then write it down correctly. So let's go ahead and write this down. That's a 2. 2. So let's do this. We have at -2 and then to the 3rd power, which looks like this. And now you don't have to do it like this, but I'm just showing you so that you can see it. It's -2 times -2 times -2. It's 3 times -2. We have a negative and a negative for our 4, so that makes +4. And then we have a minus, and then we have -1 times -1. It's twice because it's to the second power. How this works is negative times a negative is a positive, times another negative is a negative. So this is coming out as a negative. Then it's 2. 2 times 2 is 4, times 2 is 8. Then we have our +4. Then we have a minus, and a -1 and -1 is +1, so it's minus a +1. Now all we have to do is the math. You can put it in your calculator. You do -8 + 4 - 1 in your calculator, still work. -8 + 4 gives me -4 minus 1 then equal -5. A is going to be the correct answer. Okay, just stay with it. This is going to be your tricky part because you got to make sure you go negative, positive, negative. But other than that, just make sure you keep everything straightforward and you're good to go. Okay. Which of the following is equivalent to the expression 2x minus 8 minus 4 minus 3x plus 2? Okay, they're in parentheses. I will tell you this. Look out for this guy right here, or girl, whatever. They will more than likely, when given this type of problem, put a minus sign in front of the parentheses, because that's the only time that it will change whatever is in parentheses. Makes sense? So that's why they're going to assess you on it. There are 2 ways to really go about doing this. The first one, which is probably the normal way, we'll write everything down. 2x minus 8 minus 4x minus 3x plus 2 minus 5x. Okay. So then this comes out as 2x minus 8 minus 4x. You have to distribute your negative sign to everything. Minus 3x. A minus a positive 2 is still a minus 2. And then minus a minus 5 is a positive 5x. Okay. Don't forget your variables when you write these down. Those can kind of go by the wayside when you're writing something down from a computer screen. Now it's all about like terms. Combine your like terms. So you can either circle. I tell my students to circle. So if all the x's are here, circle them and circle them with their sign. So I have positive 2x and a negative 4x. 2 minus 4, or 2 plus -4 gives me -2. -2 and a -3 give me -5. -5 and a +5. Oh, look at that. It cancels itself out. So I don't even need to write these. Or you can write 0. The -8 and -2 give me -10. -10 is what this is equal to. And boom, just like that. If the x's cancel out, you've got no more x. That's why this is kind of funny too, because you're not sure. It's like, how can I get just 10 when I've got x's in my problem? And they cancel themselves out. So you'll probably double check yourself on this one. You'll say, wait a second, can this happen this way? And so on and so forth. So just be mindful of that. I told you there was another way to set this up. And the way that I would go about it is like this. Now, this may be different. And again, do what's comfortable for you. We are subtracting these 2 values. So this value is 2x minus 8 minus 4x. And subtracting this value, 3x plus 2 minus 5x. So set it up like that. Now just take them the way that they are. I've got 2x minus, right? It's 2x minus 3x. I just draw that line so you can see the train of thought. So if I do 2 minus 3, I get -1x. If I do -8 minus 2, I should get negative 10, right? And negative 4 minus a minus 5, well, that just becomes negative 4 plus 5, which is positive 1x. Now I can see that the negative 1x and 1x, when I combine them, cancel each other out, and I'm still left with negative 10. Again, you do what works for you and is most comfortable. Okay. All right. Next one. It says, which of the following is not a possible combination of side lengths for a triangle? So if you're getting this type of problem, you need to understand, it's called the triangle inequality theorem. And it basically says two sides of a triangle have to be great. The sum of two sides of a triangle is greater than the third side. Okay. So A plus B has to be greater than C. The most important thing is greater than C. So any two sides added together has to be greater than the third. So let's show you how this works. Let's take the first one. I've got 4, 7, and 10. It means that with 4, 7, and 10, if I add 4 plus 7, it has to be greater than the third, which is 10. Well, I know that 4 plus 7 is 11. 11 is greater than 10. Check. So then I do you're supposed to do it for all three sides unless we don't get one that works. So then let's try 7 plus 10 greater than 4. And I know 17 is greater than 4, so that's a check. And then the only one that's left is 10 plus 4 is greater than 7. And I know 14 is greater than 7, so that checks out. So A can be a triangle, and that's how you figure out whether or not you can have three sides. You can't just take any three random lengths and make a triangle out of them. Okay, it has to be like this. It has to be where they all work out like this. So that's the first one, and you just have to go down the line. Okay, so the next one is I've got 2, 3, and 5. So 2 plus 3 greater than 5. Okay, here's where it can get tricky. 2 plus 3 is 5. Is 5 greater than 5? No, it's not. 5 is equal to 5. So that means if you had 3 pieces of wood, and you can try this at home, if you have 3 pieces of wood and they're 2 inches or 2 sticks or straws or whatever, and they're 2 inches, 3 inches, and 5 inches, you cannot connect those 3 pieces and create a triangle. I know it sounds crazy. I know it sounds like you're kidding me, but it will not work. They will not touch each other. Okay. And that is why this cannot be the possible side lengths for a triangle. You can go through all the other ones. The other ones do work. I know even if they have same sides. So can we have an isosceles? Well, yeah. Can we have an isosceles? That's what C is. So let's try it. 6 plus 6 is greater than 5. That works out. And 6 plus 5 is greater than 6. Sorry, that's the wrong one. Then 6, absolutely. So that checks out. And then with the last one is 4 plus 4 greater than 4. Absolutely. It's 8 greater than 4. And they're all sides 4. So if it works here, it works with them all. So that's the triangle inequality theorem. If that's something that is in your specs, then it's a quick one. Just as long as you remember, it's got to be add the two and greater than. Okay. All right. Next one here. Sally bought a new box of almond milk. She estimates she will drink 500 cubic centimeters of almond milk each day. How long will it take her to finish the almond milk? Okay. It's just a compounding problem where here's the almond milk. We need to find the volume. And then once we find the volume, we got to figure out based off of how much she drinks, 500 cubic centimeters, right? Cubic centimeters, that's volume. Anything cubed is volume. So we know that volume is equal to length times width times height. And they give us 30, 20, and 10. Doesn't matter which way you do it. Honestly, anytime you do volume, it doesn't make a difference which one you do because you're multiplying all of them. So I have 30 times 20 times 10. That's going to give me 30, and 20 is 600. 600 times 10 is 6,000. And if I drink 500 cubic centimeters, right? These are all centimeters. So we're in the same unit. This is centimeters cubic. Just divide by 500. Because if we take 500 each day, let's do the math. 6,000 divided by 500 is 12. So 12 days it will take for us to go ahead and drink all the milk. All right. Okay, a little bit of exponents. First thing we want to do is write it down. Get in the habit of using your scratch paper. Even if, you're watching this video, watch it and then, pull up the problem, pause it, do it on your scratch paper, and then watch me go through it, or however you want to do it. Even if you're working on a workbook, even if you printed out the problems that we posted, make sure you're doing it on a separate scratch piece of paper so you'll get used to doing that during the test. So the first thing I do is copy it down and make sure I'm copying it down correctly, because that's the most important. You can know how to do these problems all day long, but if you put a 2 instead of a 3, or vice versa, or an A where a B should go, then it's just not going to work out for you. Okay, what do we do when we have a power out here going to everything inside here? Well, you give a power to a power. And the way that we do that is I'll go 2 to 3. So it's 3 squared. I'll do it out like this, but it's 3 squared, and then it's a 2, and then a power to a power, you multiply them. And then it's b to the second, and then it's c 3 times 2, all over a 3 b 4. Let me fix that. Okay, so now 3 to the second power, that turns into 9. Then I've got 2 times 2, which gives me a to the 4. B to the 2 stays, and then c 3 times 2 gives me 6. So then I've got, go with your numbers first. 9 over, there's nothing underneath, so my answer is going to be 9 up here. And if I know my answer is 9 already, go to your answer choices. B is not going to work because it's got a 6. D isn't going to work because it's got a 3. So I've eliminated those. The next one is A. I've got 4 on top and 3 on bottom. If there's 4 on the top and 3 on the bottom, 3 of them are going to cancel out, and there's going to be 1 left on top, right? You go by how many there are, and then the one that gets the most ends up with it. It's basically 4 minus 3. So 4 minus 3 gives me a to the 1, or just a. When I look at my answer choices, that's 9a to the 4, so that's gone. It's a positive because it's on the top, so that's gone. I already know that's going to be a. So go as far as you possibly can so you can get the right answer in the least amount of time. I know that's kind of crazy, but keep looking at your answer choices as you solve the problem, because now I'm done. There's no point in me going the rest of the way because I know that A has to be my answer. But just to double check, and some people get nervous. They're like, oh, I got it too quickly. Maybe I need to go through it. B squared over B4, it's 2 over 4. Well, there's more on the bottom than there are on the top. So it's going to cancel it out. Taking 2 away from 4 is going to give me 2. So B squared. And then there's no C's, so it's got to stay where it is, C6. And that's how you can tell A is the correct answer. Okay. All right. And finally, the last problem here. A ladder is leaning on the side of a building. It reaches up 24 feet on the side. If the ladder is 5 feet from the base of the building, how tall is the ladder? So how does this look? It looks like this. If it reaches up 24 feet, that means my building is 24 feet tall. If the ladder is 5 feet from the base, that means that I am 5 feet here, 5 feet. this is my ladder. I'll do that so you can see those are the steps to my ladder. That's how you should set this up. Because some people say, oh, 24 feet up the side of the building. Does that mean my ladder's 24 feet? But it does say how tall is the ladder. So in all honesty, it gives you the two numbers, whether you put it the 24 here and the 5 here, or you switch them around, you're still going to get the same answer. Okay. So they're not going to quiz you on whether or not you put the numbers in the right spot. They are going to want to know if you do the math right. And the math for this, anytime I've got a wall, you have to presume that it's straight up and down. Anytime you have the ground, you have to presume that the ground is perpendicular to the wall, which gives you a right triangle. If you have a right triangle, that means you use the Pythagorean theorem. So it's a squared plus b squared equals c squared. In this case, that's my c. C is always the hypotenuse. So I will do 24 squared plus 5. 5 squared equals c squared. Doing the math, 24 squared is 576 plus 25 equals c squared. So 601 equals c squared. You can't have a c squared. The opposite of squaring something is square root. So just hit your square root button and you get 24.5 is equal to c. Look over at your answer choices and right there at A, 24.5. So just in general, understand how to use the Pythagorean theorem. And because more often than not, it comes up at least once on a standardized math exam. That's just how it goes. Okay. All right. So answer key is the last one. Got to make sure you have your answers. Are there any questions? If there's any questions, let us know. But other than that, if you need to get a hold of us, if you have any questions or you have problems that you want me to go over, info@kathleenjasper.com. Okay. Thank you all for joining me tonight. I really appreciate it. Again, if you need anything, please let us know. Email us, check out our website, check us out on social media. Good session. I hope you learned something. And again, if you need to contact us, please let us know. Everybody have a safe and enjoyable week, and I will see you.